Chapter 5, we're going to start out by looking at graphing quadratic equations. On your notes, the first problem talks about rock music managers handling publicity and other business issues for artists they manage. One group's manager has found that based on past concerts, the predicted income for a performance is given by this equation, where X is the price per ticket in dollars. So graphing this equation out and looking at the graph that you have on your sheet, what happens to the income as the ticket price rises? Well, as the ticket prices rise here, you can see that the income level also rises, but only up to a certain point. As we get close to this point right in here, we can see it kind of maxes out. So the income rises until the ticket prices reach $40. At $40, we get what's called a maximum. This point we're going to be talking about today, where it hits the top, is called the vertex of a parabola. So when it gets to that vertex of $40, then the income level stops rising. After that, income decreases. And there could be a variety of factors, but probably the reason it decreases after that is people just don't want to pay more than $40 for the ticket. So less tickets are going to be bought and the income goes down. But that 40 seems to be the point where most people are willing to pay to go see that concert and still want to go to the concert. And it's also the point where they can get the most money. So this type of graph is called a quadratic function. It's also called a parabola. So we're going to be looking at parabolas when you graph quadratic functions today. Some things you should know about quadratic functions or parabolas is that they're usually going to be given to you in this form right here, where A, B, and C are going to be numbers. So those are coefficients where there'll be numbers in place there. Also, to be a quadratic, A cannot be 0. Otherwise, it turns into a linear function that we've talked about before. The C number, the last number at the end here, that's always going to be your y-intercept. Whatever that number is, that's your y-intercept. And the reason being, y-intercepts happen where x equals 0. So if you put 0 in for those x's, you end up with just whatever that C number is. So that's the place where it crosses through the x-axis. The other important thing we're going to be looking at is the vertex. And the vertex always lies on what's called the axis of symmetry. Symmetry means the parabola is symmetrical on both sides of this line. And the vertex or axis of symmetry can be found using this little equation. X equals negative b over 2a, where a and b are these coefficient numbers in the quadratic equation. Some other things you should know about quadratic equations or parabolas is the maximum and minimum values. The quadratic is always going to open up. So it's going to open up and has a minimum when A is positive. So anytime A is positive, the number in front, that number in front of the x squared in the function, whenever that is positive, it's going to open up and it's going to have a minimum low value. However, when A is negative, so when that same number ends up being negative, then it's going to open the opposite way. It's going to open down. Okay, it's going to go downwards. Both arrows are going to go downwards. And it's going to have a maximum point when A is negative. So this point right here is the highest point. We call it a maximum value. So those things will always be true when you have parabolas. All right, so what we're going to do is we're going to try and graph some things out with the parabola using some of the stuff we just talked about. One thing they want us to find is the y-intercept. Well, remember, y-intercept means what do you get when you put 0 in for x? If we put 0 in for x, all this stuff would be gone, and our y-intercept would be 3. So whatever that constant term is at the end, that's your y-intercept. Now they want us to find the vertex and the axis of symmetry. We can always find vertex and axis of symmetry with this little x equals negative b over 2a equation. So what we want to do is look at our equation and figure out what is a, b, and c. Well, a is the number in front of the x squared term. There's nothing there, so whenever that happens, we know a is 1. There's like a 1 there, positive 1. B would be the number in front of x. That's negative 6 since it's minus 6. And c would be 3. And we've already talked about c is the y-intercept. So let's plug those numbers in and see what this turns out to be. We'd have the opposite of negative 6 all over 2 times 1. Well, if we simplify that out, that's positive 6 over 2, which would equal 3. So our axis of symmetry is x equals 3. We also know our vertex is going to be at 3 something. So there's an imaginary line right here going through 3. We know that's where our parabola is going to be symmetric about that line. We also know our line is going to go through this point, 0, 3. That's our y-intercepts on the graph. We also know something else about this one. Since our a value is positive, we know that our parabola is going to open up. So we should get some parabola that looks like this when we graph this one out. Okay, so that's what it looks like. To find the rest of the values, this is where you would want to make a table. So we can make a table. We know that the parabola is going to have its minimum value at 3. So 3 might be a good one to kind of have in the middle of our table because we know that's where the vertex is. And then maybe pick some numbers bigger than that, and maybe some numbers smaller than that, and find out what those are. Now you can get those by just actually plugging the numbers in, like if we plug 0 and we already know that's going to be 3. We also know it's symmetrical, so if that value is 3, we also know at 6 it should be 3. So there's a symmetrical point over here. The other points you can get by either plugging the number actually in and figuring it out, or what we could do is use technology to come up with the table too. Let's do that. So if we go on to a graphing utility like a calculator or iPad and go to the graphing part, you can enter in the equation x squared minus 6x plus 3. Just like we did with linear functions, you can hit graph and see what the graph looks like. So we should get a graph that looks like that. And notice it does open up and has a minimum. If you want the table, you can go to your table part of it, and then there should be your values. So now we have our table. We got the values listed there. We can list those out on it. Notice that it is symmetrical. 3 is the first value, 3 is the bottom value. At 1, it's -2. Also at 5, it's -2. So those are the same. Okay, at 2 it was -5. Also at 4 it's -5. It's symmetrical, and our other part of our vertex was -6. So at 3, -6, that's our vertex point. The other points there we can graph out too. At 1 it's -2. It's also symmetrical, and at 2 it's -5. You got a symmetrical point there. Once you got all your points, connect them, and we get this U-shaped parabola, and that's the graph for this one. Okay, so not too hard once you get some of the easy stuff out of the way. Okay, for tomorrow, why don't you try this number 2 one out on the back? See if you can find the y-intercept, the vertex axis of symmetry, and also graph this one out for tomorrow. All right, let's go down to number 3. Number 3 says an object is fired straight up from the top of a 200-foot tower at a velocity of 80 feet per second. The height h of t of the object t seconds after firing is given by this equation. Find the maximum height reached by the object and the time that the height is reached. Okay, now a lot of times when we're doing word problems, we look at this information like 280. In this particular problem, and as we go here, you see that those numbers are already being used. They're already in the equation. The 200-foot tower, that's this number right here, 200. That's the starting value. That's the y-axis. 80 feet per second, that's the velocity. That's also in our equation there. There's also this negative 16, and some of you that keep going on and maybe go to do some stuff in physics or go on to pre-calc and calculus will learn that that number is associated with gravity. That's the gravity, force, that's acceleration that's pushing down on this object. So those numbers are already kind of in our equation. What they want us to do is find the maximum height reached by this object. Well, since this is a negative number right here, we know if we graph this parabola, it's going to open down, and we're going to have a maximum value at our vertex point. So if we want to find where's that maximum height reached, what they're asking us to do is find the vertex. Where's the vertex going to be located here? Well, vertex we can find using our little equation, x equals negative b over 2a, just like we did on the last couple problems. So let's fill that in and see what we get. On this one, our a is negative 16, our b is 80, our c is 200. So in our equation, we got the opposite of 80 over 2 times negative 16. While doing a little solving, that ends up being negative 80 over negative 32. And if you divide that out, that's 2.5. So what that's telling us is that the time that it takes to reach the height is 2.5 seconds. After 2.5 seconds, this is going to get to the maximum height. Now, how do you figure out what the maximum height is? Well, now that we know the x value, if we plug that in, we should be able to find the maximum height. So now we want to plug 2.5 seconds into our function right up here, and we should be able to get that value. So what we want to find is what is h at 2.5. So if we put 2.5 in there, we can solve that out. Let's see what we get here when we do that. So filling that in, h at 2.5 is going to be negative 16 times 2.5 squared plus 80 times 2.5 and then plus 200. So that now would be like a calculator problem. If you put it in your calculator, you should be able to calculate that out. And doing so, you find out that it's going to be at 300 feet. So the maximum height reached by this object is 300 feet. So anytime they ask about a maximum or minimum value, use the vertex to help it find it out. All right, we'll finish the notes tomorrow.